11-42A, and it says to add these two fractions here. And so I noticed that they already have a common denominator. So when you have two fractions with a common denominator, you just add the numerators. So it's just going to be 2x plus 10 over 3x squared plus 16x plus 5. So I wrote that down. But then there's a chance I can simplify that if I could factor both of these on the top and bottom. And if some factors would cancel out, like giant ones, then I can simplify my answer. So I was getting ready to factor. The top, the numerator, I can take a 2 out because, I don't know, maybe that's the problem, is that people don't know how to do this. So this is like 2 times x, and this is like 2 times 5. So I can factor a 2 out like this, and then I end up with x plus 5. And if I wanted to check that, I would go 2 times x is 2x, and 2 times 5 is 10. So on this, you're not doing a diamond problem, you're just factoring out the greatest common factor. That's supposed to be a 2. Okay, and then on the bottom, you need to do a diamond problem. So the way I do it is I take the coefficient of x squared, and I multiply it by the constant, and I get 15. And this is like those diamond problems that if you had CPM curriculum in middle school, you would have had to do a lot of diamond problems, where you think of two numbers that multiply to make this product and they add to make this sum. So you use the coefficient of x squared times the constant to put in the top box. And then here you take the coefficient of x. And then I already figured out that 15 is 3 times 5, but that'll never give me a 16. So 15 times 1 also makes 15, and that adds to make 16. So those are the two numbers I want. And then I take the x squared term. I think maybe your book last year put the x squared down on the bottom. I put it here because I think that's how we do it in Polydoku, is we put it up here. So I'm going to do it this way. I put the x squared term here, and I put the constant down here. And then these two are going to be the x terms, which I just did this work and figured out that I can split 16x into 15x plus 1x. And then I look at it, and I'm trying to factor it because I want it to be like this. I'm hoping that one of these two factors is going to be x plus 5, and I can cancel out. So we'll see. So 3x times x equals x squared, because this is an area model, so length times width equals what's inside the box. I can't put the 3 up here because 3 doesn't go into x, but I can put the 3 over here because 3 does go into 15, so this would be 3x times x, and that's 3x squared. And then I know that length times width, or side times side, equals area. So 3x times something equals 15, well, right? And then x times something equals x, so that would be positive 1. And then I check these. 1 times 5 does equal 5, so I know I've done it correctly. And then I get 3. See these outside ones? These are my factors. This times this equals what's inside. And what's inside is equal to this polynomial. See, because we got the x squared, 3x squared, we got the 5, we got the 16x, but we just broke it into 15x times x. So these factors multiply to make that quadratic. So that's x plus 5 right there. Okay, now I wanted the x plus 5s, or I was hoping I would get a cancellation. This is a giant 1, so they cancel out, and then I just end up with my answer. That's my answer.